Ever wonder how Spotify or YouTube instantly surfaces the most played songs or trending videos? Today, we're cracking Top K Frequent Elements, one of the most practical pattern mastery 100 essentials and a must-know for anyone aiming for a data or back-end role at companies like Google, Amazon, or Netflix. Over 50% of candidates get tripped up by time complexity here, so let's make sure that's not you. We'll use the basic framework: breakdown, assess, structure, implement, and check, which helps us communicate and design a solution step by step, better than STAR for algorithm questions. Let's restate the problem. You're given an array of integers and a number k. Your goal? Return the k most frequent elements from the array. For example, given 1, 1, 1, 2, 2, 3, and k equals 2, the answer is 1, 2, because 1 appears 3 times, 2 appears twice. Watch for cases like multiple elements with the same frequency, or when k equals the length of the unique elements. Imagine you're designing a dashboard for an e-commerce site and need to display the top k most viewed products in real time. You've got millions of product IDs in your logs. How do you surface the most popular items quickly and efficiently? A naive approach would be to count frequencies, then sort on log n time. But we can do better. First, use a hash map to count frequencies on time. Next, instead of sorting all elements, use a min heap priority queue to keep only the top k frequent elements. This way, finding the top k is on log k. Alternatively, use bucket sort, group elements by frequency in on time, then collect the most frequent until you have k. Here's our plan. Count the frequency of each element using a hash map. Option 1. Use a min heap to keep the top k frequent elements. Push frequency element into the heap, pop when size exceeds k. Option 2. Bucket sort. Create a list of buckets, where each index represents frequency, and fill them with numbers of that frequency. At the end, collect the top k elements from your heap or by iterating buckets in reverse order. Now let's implement the simple frequency map approach, counting occurrences and sorting them to pull out the top k elements. Step 1. Count frequencies. We begin by creating a hash map to store each number and how many times it appears. We loop through all numbers in the input and update their counts. If the number isn't in the map yet, we start its count at 0. This builds a full frequency table for later sorting. Step 2. Convert map entries to a list. We prepare a list to hold each number, frequency, pair. We take each entry from the map and convert it into an integer array so it's easier to sort later. Each element is simply value count. Step 3. Sort by frequency, descending. We sort the list so the numbers with the highest frequency come first. This is where the on log n time complexity appears. Step 4. Extract the top k elements. We prepare our result array of size k. We fill the result with the first k numbers from the sorted list, which are the k most frequent numbers in the array. Finally, we return the array containing the top k frequent elements. And that's how this algorithm works. It first counts how often each number appears, then sorts those frequencies to select the top k most common values. Efficient, simple, and elegant. Let's test our function with this input. We want the 2 most frequent elements in the array. The frequencies are: 1 appears 3 times, 2 appears 2 times, 3 appears 1 time. So the top 2 most frequent values are clearly 1 and 2. And that's exactly what our program outputs, 1, 2, matching the expected result. So, our implementation is correct. It correctly identifies the most frequent elements. Now let's implement the optimal bucket sort method, distributing numbers by frequency so we can collect the top k elements in linear time. Step 1. Count frequencies. We begin with a hash map that will remember how many times each number appears. We loop through the array and increment each number's frequency. This gives us a complete frequency table. Step 2. Build buckets by frequency. We create a bucket array where each index represents a frequency. Bucket at index f will store all numbers that appear exactly f times. We iterate over each unique number from the frequency map. We fetch its frequency from the map. If the bucket for this frequency is empty, we create it. We add the number into its corresponding frequency bucket. Now numbers are grouped by how often they appear. Step 3. Collect top k from highest frequency down. We prepare an array to store the final top k frequent elements. A small pointer to help us fill the result array. We start from the highest possible frequency and walk downward. This ensures we pick the most frequent numbers first. If the bucket for this frequency is empty, we skip it. We loop through every number that appears exactly f times. We place the number into our result array. This continues until we've collected k elements. As soon as we have k answers, we return immediately. No extra work needed. In the rare case k elements are collected exactly at the end, we return them here. And that's how this algorithm works. It first counts frequencies, then groups numbers into buckets by how often they appear, and finally walks from the highest frequency downward to collect the top k. Efficient, simple, and elegant. Let's test our function using this array. We're looking for the two most frequent elements in the list. We count how often each number appears. 1 appears 4 times. 2 appears 4 times. 3 appears 2 times. The two most frequent values are therefore 1 and 2. And that's exactly what our program outputs, matching the expected result. So, our implementation is correct. It returns the top k frequent elements just as intended. Spotlighting the most popular items fast is core to real-world systems, from trending videos to top products. Top k frequent elements is exactly that skill, turning raw counts into the k biggest winners efficiently. Let's do a recap. We're given an array and a number k, and we need the k most frequent elements. Conceptually, it's ranking by occurrence. Count how often each value appears, then return the top k. Ties are fine, and output order isn't important unless specified. We compared two strategies. The straightforward sort after counting works but costs on log n. To be smarter, we either keep only the best k using a min heap for on log k, or use bucket sort to group by frequency and collect from highest to lowest in on. Plan of attack. Build a frequency map in on. Choose a path. Minute heap. Push, frequency, element, pop, when size exceeds k. Bucket sort. Create buckets indexed by frequency, drop each number into its bucket, then scan from high to low until we have k. We followed that blueprint, first counting with a hash map, then either maintaining a size k min heap or filling frequency buckets. No extra sorting of the entire dataset, just the necessary work to surface the winners. We validated on examples like 1, 1, 1, 2, 3, with k equals 2, confirming the result, 1, 2. Variations with ties and edge cases like a single element array behaved as expected. The solution ran cleanly and passed the test cases. The takeaway: count first, then be selective. Use a min heap when k is small relative to n, or bucket sort when frequencies are bounded. Either way, you get scalable, interview-ready performance without unnecessary sorting.